All right, in today's video, we're going to be talking about solving rational functions. Recall that when I say the word solve, solve means to determine which values of x are going to make the equation true. We've seen a lot of different strategies to solve, and one of the big things that we've been solving for in previous units was to help us find the x-intercepts. As you can see in our first example here, solving can be a little bit tricky when you're dealing with rational functions because you've got these pesky fractions, including fractions where x is in the denominator. So the strategy for you that I'm going to suggest is to multiply everything by the lowest common denominator. That's going to clear those fractions for you, and you're going to end up solving a polynomial equation. Now, the only difference here with as compared to other solving questions you've had is you need to always state your restrictions first, okay? Because we're transforming this into a polynomial equation, you're not going to see any restrictions at the end. You want to state the restrictions on your initial question. And it's always important to be double checking your answer, just in case there's anything weird happening along the way, any type of dividing by zero. Sometimes in a rare case, you'll get these like extraneous or false roots that sometimes appear, and we can talk more about those later. Okay, let's start our first question here. Solve 2x plus 5 over 2 is equal to 3 over x. First things first, I state my restriction. X cannot be equal to 0. We cannot have a denominator of 0. All right, my lowest common denominator here, I'm going to be boring, and I'm just going to multiply all the denominators together. We have a 1, a 2, and an x, so my lowest common denominator will be 2x. I now need to multiply every term by 2x, so I'll have 2x times 2x plus 5 over 2 times 2x is equal to 3 over x times 2x. 2x times 2x is 4x squared. In our second term, the 2's cancel out, and so I'm left with 5x. And in that last term there, the x's cancel out. 3 times 2 is 6. Now this looks a lot easier to deal with. Okay, now to rearrange. 4x squared plus 5x minus 6 is equal to 0, and we know how to solve these. This is some complex trinomial factoring. I'm just going to jump right to the answer. 4x minus 3, x plus 2 is equal to 0, and I can set each of those equal to 0 to get my two answers. The first one will be x is equal to 3 over 4. And the second one is negative 2. Amazing. Now let's go through and let's check. Make sure that they're all okay. In my first one, I'm going to sub in 3 over 4. So I'll have 2 times 3 over 4 plus 5 over 2 will be equal to 3 over 3 over 4. My 2 and my 4 simplify, so I have a 3 over 2 plus 5 over 2 is equal to 12 over 3. Three over 2 plus 5 over 2 is 8 over 2. 12 over 3 is, we'll just leave that. 8 over 2 is 4. 12 over 3 is 4. We're good here. Check my other one. 2 times negative 2 plus 5 over 2 will be 3 over negative 2. So here I've got a negative 4. And I'll put that with the lowest common denominator, so it'll be negative 8 over 2 plus 5 over 2 is negative 3 over 2. And adding these together, I get negative 3 over 2 is negative 3 over 2. So both my answers are good. I can conclude with the therefore statement. I can say therefore x is 3 over 4 and negative 2. You get the idea. Okay, let's do another one. Solve 3x minus 5 over 5x minus 3 equals 3x minus 1 over 5x minus 1. Okay, we do have some restrictions here. I'm going to show the work here. We know that 5x minus 3 cannot be equal to 0. And so x cannot be equal to 3 over 5. That's our first one here. Our second one, 5x minus 1 cannot be equal to 0. X cannot be 1 over 5 either. So those are our two restrictions in place here. Many of you will be comfortable just cross multiplying. I am going to continue using the strategy where you find a lowest common denominator, because that works for all problems. Cross multiplying only works when you have this scenario of one term on one side and the other term on the other side. So we have our lowest common denominator will be 5x minus 3 times 5x minus 1. So it's my two denominators multiplied together. And so I go ahead and multiply. 3x minus 5 over 5x minus 3 times 5x minus 3 times 5x minus 1 equals 2. 3x minus 1 over 5x minus 1 times 5x minus 3 times 5x minus 1. Okay, my fractions simplify. I can simplify out the 5x minus 3 in that first term, so I have 3x minus 5 times 5x minus 1. In my second term, I have a 5x minus 1 that can simplify out, so I'm left with 3x minus 1 times 5x minus 3. Let's go ahead and expand these. 3x times 5x is 15x squared. 3x times negative 1 is negative 3x. Negative 5 times 5x is negative 25x. Negative 5 times negative 1 is positive 5. Okay, on the other side, 3x times 5x is 15x squared. 3x times negative 3 is negative 9x. Negative 1 times 5x is negative 5x. And negative 1 times negative 3 is positive 3. Okay, I'm going to combine my like terms here. Negative 3x minus 25x is negative 28x, and then I have a plus 5. Negative 9x minus 5x is negative 14x. And I'm going to rearrange, pull everything to one side. I'll have a 15x squared take away 15x squared minus 28x plus 14x plus 5 minus 3 is equal to 0. So these will go to nothing. Negative 28x plus 14x is negative 14x, and 5 minus 3 is 2. I'm going to rearrange here. X will be equal to negative 2 over, positive 2 over 14. Or 1 over 7. Awesome. And now we can check this into our original equation. So 3 times 1 over 7 minus 5 divided by 5 times 1 over 7 minus 3. Is that going to be equal to 3 times 1 over 7 minus 1 divided by 5 times 1 over 7 minus 1. Okay, let's simplify. So I have 3 over 7 minus 5 divided by 5 over 7 minus 3. And then 3 over 7 minus 1 over 5 over 7 also minus 1. I'm going to find some common denominators here. So that things are going to get easier. 3 over 7 minus 5 over 7. Nope, not 5 over 7. 35 over 7. divided by 5 over 7 minus 21 over 7. 3 over 7 minus 7 over 7, and 5 over 7 minus 7 over 7. And now because all of these have a denominator of 7, I can just divide out the 7. So now my question is 3 minus 35 over 5 minus 21 is 3 minus 7 over 5 minus 7. A lot easier. Let's scooch up here because I'm running out of room. 3 minus 35 is negative 32. 5 minus 21 is negative 16. 3 minus 7 is negative 4. 5 minus 7 is negative 2. I think we can see we're headed in the right place here. The negatives will cancel out, and I can reduce everything to just be 2. 2 is equal to 2. Our answers are good, so I can write a therefore x is equal to 1 over 7. Okay, let's look at example 3 here. First things first, we need to determine our restrictions. We've got an x plus 3 twice in the denominator, so I only have one restriction here, and that it cannot be negative 3. And because we've already got a common denominator across 2 of our terms, we're just going to use that as our lowest common denominator and multiply it by everything. So we'll have a 5x over x plus 3 times x plus 3 plus 2 times x plus 3 is equal to x over x plus 3 times x plus 3. My x plus 3's cancel out for both of the fractions, leaving me with 5x plus. I'll distribute out that bracket, so that'll be 2x plus 6 is just equal to x. I'm going to rearrange and move everything over to the other side. So I'll have a 5x plus 2x plus 6 minus x is equal to 0. And simplify. 5x plus 2x, 7x minus x is 6x. And I'll put my 6 on over to be negative 6, so x is equal to negative 1. And then we're just going to check to make sure that x is equal to negative 1 even works properly. 5 times negative 1 divided by negative 1 plus 3, all plus 2, will be negative 1 over negative 1 plus 3. 5 times negative 1 is negative 5. Negative 1 plus 3 is 2. I'll put that into a nice common denominator of 4 over 2. And then I have a negative 1 over 2 here. Negative 5 over 2 plus 4 over 2 is negative 1 over 2. Our sides are equal, which means that negative 1 is indeed our answer. Therefore, x is equal to negative 1. Okay, and one last example here that we can work with. Solve 5 over x minus 1 minus 12 over x squared minus 1 is equal to 1. I am going to first factor my second term here. I'm going to factor the denominator because I can see that this is a difference of squares, and factored form is always easier to work with. So the difference of squares will be an x plus 1, x minus 1. Again, all equal to 1. So in terms of my restrictions, I have 2 terms in my denominator with a repeat of an x minus 1. So both of those are going to be our restrictions. In this case, x cannot be equal to negative 1 or positive 1, or you could just write x cannot be equal to plus minus of 1. Okay, let's solve here. Start with our lowest common denominator. I already have an x minus 1 in both of my terms on the left-hand side. So my lowest common denominator is just going to be x plus 1, x minus 1. And I'm going to multiply every term by that. including the term on the other side. Okay, let's go ahead and simplify. In my first term, the x minus 1's cancel out, leaving me with 5 times x plus 1. In the second term, the entire denominator cancels out, and so I'm just left with a negative 12. But on the right-hand side, nothing cancels, and so I'm just left with x plus 1 times x minus 1. I'm going to expand everything. First distributive property, 5 times x is 5x, 5 times 1 is 5, all minus 12. And then here I'll just FOIL it out. This will be an, actually this is our difference of squares, so it'll be x squared minus 1. And let's bring everything over to the left-hand side to see if we can combine any more like terms that way. So I'll have a negative x squared out front. 5x is my only term with an x in it, so I'll have a 5x. Then I have a 5, a negative 12, and then this will become positive 1 when it comes over. 5 minus 12 is negative 7, plus 1 is negative 6, all equal to 0. And I'm just going to flip all the terms on this to make it a little bit easier. I'm multiplying everything by negative 1. Because I have 0 on the other side. So now I'm looking for two numbers that multiplied together equal to positive 6 and added together equal to negative 5. Those two numbers are negative 2 and negative 3. So I have two possible answers here. It's either that x minus 2 is 0 or x is negative 2. Or x minus 3 is 0, x is positive 3. And sorry, the 2 should be a positive 2. So now I need to check both of these into my original equation here. Our first check is going to be at x is equal to 2. And my original equation, I'm just going to bring it on down. There we go. And I'm going to substitute that in. 5 over 2 minus 1. Minus 12 over 2 plus 1 to minus 1 equal to 1. 2 minus 1 is 1. 5 over 1 is 5. 2 plus 1 is 3. 2 minus 1 is 1, so I have a denominator of 3 here. 12 over 3 is 4. 5 minus 4 is indeed equal to 1. So we're good for the x is equal to 2. The second one we have to check is x is equal to 3. So I'll put that in. 5 over 3 minus 1 minus 12 over 3 plus 1, 3 minus 1. 3 minus 1 is 2, so I have a 5 over 2. Here I have a 12 over 3 plus 1 is 4. 3 minus 1 is 2, so 4 times 2 is 8. I'll reduce my second term there by dividing everything by 4. So I'll get 3 over 2. 5 over 2 minus 3 over 2 is 2 over 2. And 2 divided by 2 is 1. 1 equals to 1. Both of our answers are good, so I will write a therefore statement up top here. Therefore, x is equal to either 2 or 3. Okay, so to recap in terms of what we did here, for every single one of these problems, we found a lowest common denominator. We started by stating restrictions. We found the lowest common denominator and then multiplied that by every single term in the equation. We reduced, and then we solved as if it was a polynomial function or polynomial equation. Okay, pretty straightforward. Good luck, everybody.